So moving into section 5.2, we're going to look at what are called the sum and difference formulas, specifically for sine, cosine, and tangent. We can do similar things with cosecant, secant, and cotangent, but we're going to focus on the main three here. Where to understand why we care about these, let's think about two very basic scenarios, looking at the value of cosine of 105 degrees and sine of 45 degrees. Where with these, if there's mathematical justice, you could split this up into cosine of 45 and cosine of 60, and then this you could think of as sine of 45 minus sine of 30, and all would be nice and easy because you didn't break things into pieces and you don't have to worry too much about them. You find the nicer parts that work for the not so nice parts. But unfortunately, that's not how this works out. There's a little bit more to it when you have something of this form, when you have something that seems like its parts come from nice places, but that aren't as nice in and of themselves. Where for this, we have our sum and difference formulas. That is, our sum and differences of angles. So, if we have some expression of form cosine alpha plus beta, where alpha and beta are angles, we have that we can express cosine alpha plus beta as cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Meanwhile, if we have something of form cosine of alpha minus beta, we can write that as cosine alpha cosine beta plus sine alpha sine beta. And if we have something like sine of alpha plus beta, we can turn that into sine of alpha cosine beta plus cosine of alpha times sine of beta. And then finally, if we have something of form sine of alpha minus beta, we can write that as sine of alpha cosine of beta minus cosine of alpha sine of beta. So, if we want to take something like this and use those values to find the exact value of cosine of 105 degrees and sine of 15 degrees, what we would have to do is recognize where these fall in terms of our formulas. That is, for that first case, for finding cosine of 105 degrees, we can understand that cosine of 105 degrees is the same as cosine of 60 degrees plus 45 degrees. So, in terms of that first equation, alpha plus beta form, we can split this up as cosine of 60 times cosine of 45 minus sine of 60 times sine of 45. And I ran out of space, but you get the idea. And then from here, we're just evaluating at known values. So, kind of like how in 5.1, a lot of what we did relied on being comfortable with known values of the fundamental identities, known things we can do with things like the relationship between sine and cosecant, or tangent and sine and cosine. Here, a lot of what we do relies on knowing these basic angles, especially those in the first quadrant of the unit circle. But from there, we can evaluate all of these, where we have that cosine of 60 degrees is 1/2, while cosine of 45 is root 2 over 2, minus sine at 60 degrees, or sine at 60 degrees, is root 3 over 2, and that is another 1/2. Stick these together, multiply the 1/2s in, you get common denominators, and we will end up with a value of root 2 minus root 6 over 4. And if you want to get that approximately, I think it ends up being something close to 1/4. But this would be the best form to leave it in because it's rationalized and it's exact. Meanwhile, for the second case, for sine of 15 degrees, like we thought, we want to think about this in terms of 45 and 30, because those are nice angles for sine. We can think of this as sine of 45 degrees minus 30 degrees, and use that formula for difference of sines, where this will give us sine of 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30. And again, I ran a little low on space, but the idea, where same sort of thing as before, it's just we're spinning around different numbers. Sine of 45, though, is still root 2 over 2. Cosine of 30 will end up being root 3 over 2. We have, for the cosine of 45, another root 2 over 2. And the sine of 30 is now 1/2. Multiply things together, pull them apart as needed, and we get root 6 minus root 2 over 4. So very similar, actually, to that value up there. It's just an additive inverse. So I actually had it wrong. This should be about negative 1/4, and this is about positive 1/4. But essentially the idea here is take something that's not really obvious to look at and pull it apart into more manageable pieces. And I know what you're thinking looking at this, why don't we just use a calculator? Well, for one, this hints at what a calculator might do with this kind of problem, because calculators are good at recognizing this kind of pattern where they're available. And then also, this is a neat trick to understand how these trig functions work. And in our next example, we're going to see how we can use them in the context of something more like what we saw in 5.1. That is, where we want to verify an identity rather than just spin some numbers around.